In today's lesson video, we're going to start Unit 5 by talking about the Pythagorean Theorem. Now, in Unit 5, we're dealing with something referred to as right triangles and trigonometry. And so all of what we do in Unit 5 is going to be based on what we can do with right triangles and the relationships of sides and angles within a right triangle. So we start off with the Pythagorean Theorem, which I'm sure you've heard before and used before in other classes. But the Pythagorean Theorem states the equation, you guys always remember, a squared plus b squared equals c squared. That's all fine and good, but we need to remember what those apply to and what those things actually mean. So the Pythagorean theorem can be used to find missing sides of a right triangle. Okay? And so understanding A, B, and C as sides of the right triangle is going to be helpful here. So as we look at this given triangle, sides A and B are these two sides that make up the right angle. Okay, sides A and B are called legs because they make up the right angle. And then the third side, C, is called the hypotenuse. Okay, C is called the hypotenuse, and it is always the longest side, and it is also across from the right angle, or we might say opposite the right angle. Okay, so understanding which sides A, B, and C are is going to be an important step as we use the Pythagorean theorem to find missing sides. And so today, as we work through our examples, when we find each missing side, there are two ways I'm going to specify the answers. I'm going to ask for either an exact answer or an approximate answer. And so here's what that means. When I ask for an exact answer, it should be a simplified radical. Okay? We learned in that Unit 5 intro video how to simplify radical expressions or square root expressions and using perfect squares. If I ask for an approximate answer, that's when you get to round to the nearest whatever they request. In this case, if they don't tell you, always assume we're rounding to the nearest tenth. Okay? So for the first example, we are asked to give an approximate answer. That means we're going to use a rounded answer. Okay? And as we look at this, we are going to need to first identify which sides are which. So here's what I want you to do as we work through Pythagorean theorem problems. I want you to start by writing the Pythagorean theorem equation. A squared plus b squared equals c squared. In order to do that and use that, we need to label the triangle with sides A, B, and C. The legs can be A and B, but the C has to be the hypotenuse. So it's really kind of important to start with C. The hypotenuse is this side on the bottom because it is the longest and it's across from the right angle. That means A and B can be either 10 or 5. It doesn't matter which one is which. But those are the legs. So I'll say A is 10 and B is 5. Now I can plug back into this equation. 10 squared, oops, not plus B, let me fix that, plus 5 squared, because I know B is 5, has to equal this unknown length C squared. And so now we can start to solve this equation. So here's a review of how to solve an equation in the Pythagorean theorem. The first part you do is square those numbers that you have. You do exponents first. 10 squared is 100. 5 squared is 25. That equals c squared. So as we go through this, now we add those together. 100 plus 25 is 125 equals c squared. Now, to find out what c is, to get c all by itself, what we need to do is take the square root of both sides of this equation. That's because to cancel out or undo c squared, we do the square root. A square cancels out a square root cancels out a square. So we take the square root of both sides. So we can say that c is the square root of 125. Okay, but we want an approximate answer, so we're going to use our calculator to do the square root of 125. And I'm going to show you very quickly where to find that square root feature of your calculator. So I'm going to bring up my calculator app. Okay, this is a good one I've got on my iPad. You can get it on your phone if you have an iPhone. It's called Calculate 84. What I want you to do to find the square root is look on the left side here. You'll see the x squared button. And we're going to hit the second key to bring up that feature. Okay, so when I do the second of x squared, it brings up the square root. And that number I'm using was the square root of 125. So I put in the square root of 125 like that, hit enter, and we get about 11.18 and so on and so forth. We're rounding to the nearest tenth. That's one decimal place. So this would be 11.2. So the square root of 125 is about 11.2, and we are given units of measure, so we're going to write miles. That's our answer. Okay, so we're going to try another one where we're doing an exact answer. Okay, same setup. We have a right triangle. We want to use the Pythagorean theorem, so we're going to write that out. It's not plus, equals c squared. And now to keep going here, we're going to need to label A, B, and C here. This time, the hypotenuse across from the right angle is the 9. Okay, that means 7 and x can be A and B, and it doesn't matter which one's which. I'm going to call x my A side and 7 my B side. Okay, that way I start my equation with x squared plus now 7 squared must equal 9 squared. This time, the variable, the one we're looking for, is one of the legs, so I cannot just add 7 squared and 9 squared together. I'm still going to do the exponents first, so I'm going to rewrite my equation as x squared plus 49. 7 squared is 7 times 7, not 7 times 2. 7 times 7 is 49, and 9 squared is 81. And now we need to subtract 49 from both sides. And when I do subtraction here, 81 minus 49, on the right side of that equation now, that equals 32. So again, I'm going to take the square root of both sides. And when I take the square root of 32, I'm not going to use my calculator for that. This time I'm going to write an exact answer. So I know x is equal to the square root of 32, but I'm going to do this by simplifying this radical like we did in the previous video, in the intro video for Unit 5. So as a review for that, what we want to do is split this number into two square roots that are both factors of 32, meaning if I multiply these two new numbers, I get 32. And what we want to do is we want to find the biggest perfect square that we can divide 32 by. So really quickly, I'm going to remind you that our perfect square numbers are 1, 4, 9, 16, 25, 36, 49, 49 was 7 squared, 8 squared, 64, 81 is 9 squared, 100, 121, 144, and we could keep going down the list, but that's a good enough list to get us started. So I want to see what is the biggest number from that list that you can divide 32 by. As you start checking and dividing with your calculator, you'll hopefully get up to 16. Okay, 16 is the biggest one of these numbers that you can divide 32 by, because 32 divided by the 16 leaves you with 2. So the two numbers we put back in here should multiply to equal that 32. Now, as we go to simplify this, the square root of 16, we can actually take the square root of that number. That's why we break it down into a perfect square, because the square root of a perfect square is a whole number or a positive integer. So the square root of 16 is 4, so I rewrite it as a 4. I don't put my square root there anymore. But then the root 2 at the end stays. So what you're really saying is 4 times the square root of 2 is my answer. And so we kind of make that look neater by getting rid of our dot for multiplication. And so we just write it as 4 square root of 2, or 4 radical 2. That is your answer in simplest radical form. Okay, that's an exact answer. Okay, we'll start going through them a little more quickly. Number 3, again, we're going to do an approximate answer here, which is really good because I'm giving you units, I'm giving you lengths that are already decimal values. So our answer can be a decimal pretty easily. Again, start with a squared plus b squared equals c squared. All right, we're going to fill in sides a, b, and c. It's still a good idea to label these sides. C is actually this side here because it's across from the right angle, so we know that's C. And A and B can be the other two sides. It doesn't matter which one is which because we can change the order of addition and it'll still be okay. So this time, if A is x, this becomes x squared plus 19.1 squared equals 30.5 squared. So we're going to do some math here. We're going to do 19.1 squared. And that is 364.81. You're going to get big numbers every once in a while. Then we're going to do 30.5 squared. Another large number, 930.25. But we do this still kind of the same way we did the last one. We just subtract this number from both sides. That's why it's really important to show your work neatly and clearly. When I subtract 364.81 from both sides, I get that x squared is 565.44. And now we're ready to do the square root of both sides. This time we get to use that feature of our calculator. We can do the square root of 565.44 and round to the nearest tenth. When I do that, I get 23.778982232 rounded to the nearest tenth makes it 23.8. Okay, let's keep moving. This next example is a little more complicated because you see that it has this square root of 82 as a side already. This is not just the number 82, so we need to be careful how we enter this when we do this problem. We're still going to start with a squared plus b squared equals c squared. Okay. A and b are the legs, c is the hypotenuse. That means this time that x is my c. So a can be this one and b can be this one. So when I set this up and I do a squared, I'm taking this square root of 82 and I'm squaring all of that. So I like to use parentheses to show that I'm squaring that number. B is 4, so b squared is 4 squared, and that equals x squared instead of c squared. All right, now this is the part that is really, it kind of looks complicated, but it's not. When you square a square root, those cancel each other out, as we kind of talked about up here. When you square root a square, those cancel each other out. So all I'm doing is canceling the square root of the 82, and that just gives me 82. But 4 squared, we get a new number there. 4 times 4 is 16. And now we can add those together. 82 plus 16 is 98. Okay, so again, we want to take the square root of both sides. So x is the square root of 98, but here they're asking for an exact value. So I want to split this into two radicals, where the first one here is our biggest perfect square factor of 98, or the biggest perfect square you can divide 98 evenly by. If you look back up at our list, we start dividing out. Hopefully you recognize that 98 is 2 times 49. Okay, so I know I can divide by 49 pretty easily. So 49 is the biggest perfect square factor of 98, so it goes first. The other one is 98 divided by 49, which would be 2. Then we can take the square root of 49, which is just 7, and put the root 2 after it. And our unit of measure this time is centimeters. Okay, let's keep moving. For this problem, you need to be careful about how you do this. It looks like there's too much information. It looks like the legs are 14 and 29, hypotenuse is x. But pay attention to this. The hypotenuse must be opposite from the right angle. There is no right angle here. Okay, that is not marked as a right angle. This is not one big right triangle. However, if you look at this with the right angle there, this is actually 2 right triangles stuck together. So as we look at this, we've got a right triangle here, but we also have a right triangle here, where this is the right angle. So x is actually going to be composed of 2 other pieces. So what I'm going to do, I'm going to pick 2 completely different variables. Okay, I'm going to pick two new letters completely. Let's do Y and Z. Okay, that shows you that Y is one part of X, Z is the other part. Remember, part plus part equals whole. So X is equal to Y plus Z. So I'm actually going to treat this as two separate problems. I'm going to use right triangles within a bigger problem. Okay, so first I'm going to look at finding Y. All right, Y, you should recognize, is a leg of this left side right triangle. The other leg is 12, so those are A and B. And then 14 is C. So that Pythagorean theorem looks like this. Y squared plus 12 squared equals 14 squared. So what I'm going to do here, we've been doing Pythagorean theorem quite a bit. You should be getting a little bit better at it. I want you to pause the video here and work this out and find the value for Y. Okay, so we're going to start filling in blanks up here to add up two numbers and get the total answer for X. Find Y by using your Pythagorean theorem here. Okay, and when you're ready, push play to check your answer, and then we'll move on with the rest of the problem. All right, this is what we should get. Y works out to be about 7.2, and we can write an approximate answer here because it says that our final answer should be approximate. So Y, the first little piece of this length of X, is 7.2. I need to find the rest. So now we're going to focus on finding this other part, Z, okay, from here to here. Again, that's a leg of the right triangle. I can call that my leg A. B is still 12. Then the new hypotenuse is 29. So this looks like this. Z squared plus 12 squared equals 29 squared. Okay, so what I want you to do again, pause the video here. When you're ready to find your answer for Z, or you think you have it and you want to check, click play. All right, this is what we should get. Z should equal 26.4. Okay, so when I add those together to get my length for X, I should get 33.6 for a total length. Okay, so in a lot of these problems, we're going to have issues where we are using right triangles within a bigger problem or another problem. Like number 6 here, we don't even have a right triangle drawn here. We have a trapezoid. There are some right angles though, but here's what I want you to recognize. This length of X we're looking for, it's not a side of a right triangle, or at least it doesn't look like that. So I want to see how it relates to a right triangle. Well, if I did this, if I kind of copied that and I slid this over like this, you'll notice that this trapezoid, this four-sided figure, actually looks like a rectangle and a triangle stuck together. And that triangle is a right triangle, where this length, X, is got to be equal to this X, because they're opposite sides of that rectangle. Okay, and so I do have a right triangle here, where the hypotenuse is 16. One leg, A, is X here. I need to be careful with this other leg. This other leg is not 18. This other leg is 18 minus this length 5, because again, opposite sides of that rectangle are congruent. So 18 minus 5 is 13. So B is 13. So when I do A squared plus B squared equals C squared, A I'm going to call X, B I'm going to call 13, and C I'm going to call 16. So as we go through this, now we can find X this way, and that'll be our answer. So again, pause the video, try this one on your own, and then you can check your answer. All right, this is what we should get. On this problem, X is actually just equal to the square root of 87. You can't split this anymore. When you try and check your perfect squares, there isn't a perfect square that you can divide 87 by evenly other than just one. So this is our final answer for X as an exact answer. Okay? Let's keep moving. The last part of our notes here, we're going to focus on some application problems where we're going to be given a word problem. But again, the emphasis is that we're using the Pythagorean theorem. So we need to have a right triangle. So each of these situations can be represented by a right triangle. So the first thing you're going to need to do is draw a picture. Now, before you just draw any old right triangle on your page, you need to read carefully so you understand which parts you're going to need to draw. So in this first one, a rope from the top of the mast. Now here's what a mast is on a sailboat. It's that vertical beam going up and down that helps hold the sail. And it's always perpendicular to the deck at a right angle to the deck. Okay, so that top of the mast has a rope attached to it that is also attached to 15 feet away from the bottom of the mast on the deck. So if that rope is 32 feet long, how tall is the mast? Well, let's start to draw this. We know that our mast is our vertical piece, up and down. We have a rope going from the top of that mast to another point down on the deck, but that other point is not right here at the bottom. It's 15 feet away from the bottom on the deck. So that's our 15 feet, and this is our rope. There's your right triangle. Okay, we've got our mast going up and down, the deck horizontally along the bottom, which is 15 feet away, so we're going to mark that as a length of 15. Now, we also know that the rope is 32 feet long. Well, the rope in this case becomes our hypotenuse, okay? What they're looking for is the height of the mast. How tall is the mast? So H for height or T for tall, or just use an X. And now we have a Pythagorean Theorem's equation we can set up. So I'm going to go through that part kind of quickly. H squared plus 15 squared then would have to equal 32 squared. Okay, and if we did our Pythagorean theorem and we did 15 squared is 225. Okay, 32 squared, let me get my calculator out, is 1024. And I subtracted 225 from both sides. We get h squared is 799, but remember we have to do the square root now. So h is just 28.3 feet. And we can approximate to the nearest tenth, round to the nearest tenth, on all these application problems. It says so in each problem. Okay? So what we're going to do is I'm going to go ahead and help you see the drawing part of this in the next few problems, but I'm going to let you do the Pythagorean theorem parts on your own. At the end of the video, I'll quickly show you what your answer should be. Okay, so number 2, Kurt is building a rectangular deck with the dimensions 10 feet by 23 feet. So what's the length of the diagonal of the deck? Again, you want to focus on a drawing that has a right triangle in it. Well, rectangular deck is just a rectangle. We don't really care how you align this on your paper, but the dimensions are 10 feet and 23 feet. Well, the shorter side would be 10 feet, the longer side would be 23 feet, and it's asking for the diagonal. There's a right triangle. Okay, we can almost even get rid of the other part of this deck and just focus on the right triangle. So we're given a side A, that's a leg. B, that's a leg. We're looking for the diagonal. That's our hypotenuse. So 10 squared plus 23 squared equals C squared. Okay, and you can work through that and find what C is. Like I said, at the end of the video, I'll let you check those answers. But for the sake of time, we want to move right along. I want us to look at the next one. A roofer has leaned a 16-foot ladder up against the side of a house. If the base of the ladder is 5 feet from the house, how high does the ladder reach? Round to the nearest tenth. So in this case, again, we've got a situation with a ladder leaning on a house. We've got the house, we've got the ground. That kind of helps you visualize what your right triangle should be. Okay? The ladder itself is this hypotenuse. The house is up and down, and then this is the ground. Okay, forms a right angle. There's your right triangle. The ladder is 16 feet. Okay, it's a 16-foot ladder, so I know the hypotenuse is 16. The base of the ladder is 5 feet away from the house, the base being the bottom here, so I know this length is 5. How tall or how high does the ladder reach? That's our height going up the side of the house, h. So here's our Pythagorean theorem. H squared plus 5 squared must equal 16 squared. Again, you can work that out and find your answer that way. These answers will be at the end of the video for you to check. Okay, we can approximate all of these round to the nearest tenth. On number 4, This is one I really want us to pay attention to how we set it up, okay? It's giving you these towns, Cabbagetown, Atlanta, Midtown. These are all towns, and it's giving you their distances on some map, and we need to find one of the missing distances. Again, focus on how to make this a right triangle, but you need to remember your cardinal directions, your north, south, east, west. North and south, east and west. Never eat sour worms. That's how I was told to remember it. So when it says Cabbagetown is 4 miles east of Atlanta, okay, remember east is going this way. If Cabbagetown is east of Atlanta, that means Atlanta is west of Cabbagetown. So Atlanta has to be the one on the west side. Cabbagetown has to be on the east side. Okay, so there's a length between them, or a distance between them, of 4 miles. Then it says that Midtown is 7 miles north of Cabbagetown. So from Cabbagetown, we go straight north to Midtown, 7 miles. There's your right angle, and if I connect Midtown to Atlanta, there's the hypotenuse, making it a right triangle. And that's what they're looking for. This distance, we'll just call it C, because it is the hypotenuse. So in this case, your Pythagorean theorem is 4 squared plus 7 squared equals C squared. And then we would square the 4, square the 7, add them, take the square root, and that's how you get those answers. So this is going to be really important. Focus your drawings on some kind of right triangle and just pay attention to things like direction and things that you would normally visualize on a map or in a real life picture. Like I said, here are the answers for 2, 3, and 4, so you can check your work. Okay, number 2, we should get 25.1 feet, rounding to the nearest tenth again. Number 3, the length, height up the side of the house would be 15.2 feet, again rounding to the nearest tenth. But on number 4, and I apologize if you made a mistake on here, it does tell you to round to the nearest whole number. That's the ones place, so not using the decimal. So this would be 8 miles. You probably rounded to 8.1 if you didn't catch that, but we would round that to 8 miles total.